Alright, so in this problem, a ball is tossed up and caught by the thrower. Okay, and once again, we're asking how. In this problem, we're asking how long is the ball in the air. So we start with our chart. Let's fill things in. Delta x, vi, vf, a, delta t, and let's start filling this in. So we know it's tossed up at 25 meters per second. So we know that this is true. We also know the acceleration, negative 9.8 meters per second square, and we're looking for the time. Okay, so we ask, what is the third condition here? So again, let's go back to the physics in the problem. We have the ball, we're tossing it up, and it's going up, and then it's eventually coming back down. So the ball comes back down to the starting location. Okay, and oops, where's my pen? Okay, so it's going to be right back where it started. So if the ball goes up and comes right back down, then what we know is that its displacement is equal to 0. So the displacement of the ball is equal to 0, and now we can proceed with the problem. So we do not care about equation, we do not care about VF, so we're going to use equation 3, which is delta x equals VI delta t plus 1/2 a delta t square. And as we use this equation, what we know is we know that 0 is equal to 25 times delta t plus 1/2 negative 9.8 times delta t square. Okay, as soon as you see this, you feel that, or rather you notice that this is a quadratic equation. However, anytime you have one of the terms in the equation ax squared plus bx plus c equal to 0 missing, okay, so if you have b missing or c missing, you really do not need to use the full quadratic equation formula. It just would be a waste of time. In this case, the constant term is missing, and so the best approach would be to simply factor out the time. So we can do delta t equals 25 minus 4.9 delta t. And now once we've done this, we see that we have a product of two quantities that is equal to 0, and we know that then at least one of them has to be equal to 0. So either delta t is equal to 0 or 25 minus 4.9 delta t equal to 0. Okay, so the first one of course implies delta t is 0, and then the second one says that delta t is 25 over 4.9, which will happen to be 5.1 seconds. Okay, so the answer that we'll choose is going to be 5.1 seconds, because that's when the ball has actually left the hand and it's it's in the air and it comes back down. Okay, so that'll be the physically valid answer that we'll choose. All right.